Hello children, in this lecture we will discuss general properties of transition elements. So all the transition elements of a particular series are having different number of electrons in n-1d shell but similar electrons in ns shell. Okay students, so variation in the configuration in the outermost shell due to difference in the number of electrons in d subshell, but electrons in ns shell are similar in all the atoms of a particular series. Now the properties of transition elements, and the first property is atomic radius. So in general terms, you know that the distance from the center of the nucleus to the outermost shell of an atom is known as its atomic radius. Okay, so according to the first point, in general, the atomic radii of transition elements belonging to a particular series decreases with the increase in atomic number. Okay, the decrease becomes small after midway. Now, what is the reason of this? So, atomic radius decreases in the series due to increase in nuclear charge. Okay, students, but with increase in the atomic number, the effect of the increased nuclear charge due to increase in atomic number is counterbalanced by the increased shielding effect of the n-1d electron, and this is why the atomic radii remain almost constant after midway in each series. Okay students, so the increase in atomic number is counterbalanced by the shielding effect, increase in shielding effect due to the shielding of n-1d electrons. Okay, and that is why after midway the transition elements are having almost same atomic radius. Second point, near the end of each series there is a slight increase in the atomic radius, and this is because towards the end of a series the electron repulsions between the added electrons in the similar orbitals predominates over the attractive forces, and due to the increase in nuclear charge. Okay, so the repulsion is predominates over the attractive force due to the increase in nuclear charge, and that is why at the end of the series there is slight increase in the atomic radius. Okay students, the next point is the atomic radii of transition elements increases on moving down the group. However, the atomic radii of the element of second and third transition series are nearly the same. So the increase in atomic radius on moving down the group is due to the increase in electronic shells. Okay, and this is why the atomic radii of the elements of second transition series are larger than those of the first transition series. Now the second explanation, the almost similar values of atomic radius on the elements of second and third series is due to the Lanthanide contraction, and this contraction is due to the filling of 4f orbitals. Okay, so the contraction in the radius or decrease in the radius due to the presence of 4f orbitals are known as Lanthanide contraction. The next heading is Ionic Radii. Okay, so the Ionic radii of transition elements follows the same trend as the atomic radii. Okay, but there is difference in the ionic radius due to various oxidation states of the ions. Okay, so in general, the ionic radius decreases with increase in oxidation state. Okay, for example, the radius of copper plus ion will be more than copper 2 plus ion. Okay, so with increase in oxidation state, atomic radius decreases generally. Then the ionic radii of the transition elements are smaller than those of the representative elements of the same period. Representative elements, students, means elements of S and P block elements. So the elements which of S and P block which are present in the same series will have higher radius than the transition elements. Okay, students. Then metallic properties and lattice structures. So all D block elements are metallic elements. All are metallic elements, and they all carry typical metallic properties. Typical metallic properties like metallic luster, malleability, ductility. All these properties are also present in transition elements. Okay, students. Now, the metallic character of transition elements may be attributed to their low ionization and enthalpies. So, all the transition elements are having low ionization enthalpy and the presence of several vacant orbitals in the outermost d subshell. So, these are the two reasons for their metallic nature: low ionization enthalpy and presence of vacant d orbitals. And the half-filled d orbitals are also responsible for the formation of dd metallic bonds, metallic covalent bonds. And due to the formation of these covalent bonds, the transition elements or transition metals are comparatively harder in nature. Comparatively harder in nature. Okay, so since transition elements exhibit metallic properties and are quite hard, it appears that both metallic and covalent bonding exists together in these elements. So covalent bonding is due to the half-filled d orbitals. So these half-filled d orbitals overlap with each other and forming covalent bonds. And metallic bond, so typical metallic bond means the bonding between kernel and mobile electron. So you all know that kernel represents the positively charged ion of the atom, and these mobile or free electrons are the vacant electrons of the related atom. Okay, so the bond formed due to the electrostatic force between these two oppositively charged units is known as metallic bond, and the bond formed due to dd sharing of electrons are known as covalent bond. So these two types of bondings are present in transition metals. Okay, and that is why they are showing extra hard structure. Next property of the transition elements is ionization enthalpy. So the ionization enthalpy of transition metals is more than S block elements but less than P block elements. Okay, students, because these elements are present between the S and P block elements. Now, some important point of the ionization enthalpy. The first point, the ionization enthalpy of transition metals are quite high and lie between those of S and P block elements. Why this is quite high value of ionization enthalpy? Due to the smaller atomic radius and high nuclear charge. Due to these two reasons, the transition elements are showing comparatively high ionization enthalpy. Then second point, the first ionization enthalpy increases with increase in atomic number across a given transition series, although the increase is not very regular. Okay, students. So reason for this particular question, the increase in ionization enthalpy with increase in atomic number across a given series is due to the increase in nuclear charge. Okay, but the added electrons enter into n-1d subshell and shield the valence electrons from the nucleus. That is why the effect of the increased nuclear charge is opposed by the screening effect of n-1d electrons. Okay, students. Then third point, the first ionization enthalpies of the elements of third transition series are higher than those of the elements of first and second series. So why this is so? Because in the third series elements there are presence of filled f orbitals, and the f orbitals exhibit poor shielding effect. Okay, due to their peculiar shapes. As a result, the valence electrons experience greater nuclear attractions, and that is why greater amount of energy to required to ionize the elements of the third transition series. And this is why the ionization enthalpies of the elements of the third transition series are much higher. Okay, students. The next property is oxidation states. So transition elements are showing a number of oxidation states, number of variety of oxidation state, except a few exceptions. Okay, so few elements which are not showing number of oxidation state, but generally all the transition elements are showing a number of oxidation state. The ability of transition elements to exhibit several oxidation state is a characteristic property of these elements. Okay, students. So the points are related to this property. First, we will do the explanation part, why these transition elements are showing number of oxidation state. Because in transition elements, the configuration of valence shell is n-1d from 1 to 10 electrons, and in ns shell 1 to 2 electrons. So at the time of bond formation, these transition elements can use electrons of ns shell and of n-1d shell also. Okay, students. So due to the participation of electrons of penultimate shell, the transition elements can show a variety of oxidation states. Now some important discussion related to oxidation state. Okay, and these points are very important, students. Number of reasoning can be asked here from these points only. So the most common oxidation state of the elements belonging to the first transition series is +2, which arises from the loss of 2 4s electrons. Okay, then the second point, the bonds formed by transition metal in +2 and +3 oxidation states are mostly ionic, and at higher oxidation state are mostly covalent. Okay, students. Then next point, within a group the maximum oxidation state increases with atomic number. Okay, the next point, the highest oxidation state of a transition metal are found in their fluorides and oxides. Why? Because these two elements are highly electronegative. Fluorine is highest electronegative and the oxygen is next lower than fluorine. So the highest oxidation state of the compounds of the D block elements is found in its fluorides and oxides. Next point, the highest oxidation state is 8. Highest oxidation state is 8. Transition metals can show lower oxidation state also, like +1 and 0. As you can see here in nickel tetracarbonyl, nickel is with 0 oxidation state. The stability, relative stability of a particular oxidation state in aqueous medium can be known on the basis of standard electrode potential. Okay, if more negative or less positive the value of standard electrode potential, then greater will be the stability of the ion of that particular element. Okay, students, so lower or less positive value of the standard electrode potential, standard reduction potential, so greater will be the stability. Okay, students.